Welcome to the second part of this solid modeling demonstration regarding the Geneva mechanism. And uh, in the first part, we modeled these components. I actually skipped most of that, just showed the sketch for the Geneva wheel itself. Then we assembled all of them. Notice that we have over here our ground link was our first component for this assembly. Then we had two sub-assemblies that we made. One being the driver, the other one being the Geneva wheel itself with its shaft. And now we're going to use this to show how a motion study can work in the SolidWorks program. So for starters, you'd think in solid modeling that these things would actually be solid. Well, it knows where these things are, but it still doesn't use actual physics to model them. So I can just take this and swing it right in here, and I can take this one and do the same thing. So we've got this crossover, this interference that it just doesn't stop you. So we're going to use this motion study to see how these two things can actually interact physically, which should be kind of cool. Now for starters, before we even get to clicking on this motion study, we need to set this up so that first off there's no interference between the two parts. If it starts off with interference, as I think we can see right here, there's a little bit of interference between them, then the motion study will not move forward. So we need to make sure that they're clear. The second thing we want to make sure of is that this pin is going to go right into the slot the way it's designed to do. So if we do one, we should be able to do the other as well pretty easily. So we want to make sure this is going to work. Right there we can go here, make sure we're looking at it from the very top. And it's going to contact pretty well here, but there's a little bit too much clearance here. So I want to make sure that first off it does clear this point, but that it contacts here at a pretty decent angle. You want it to just glide right onto that spot. So that's good. So let's go back here and make sure that there's plenty of clearance. Looks like you've got a little bit of space there and a little bit of space there, all the way through. It looks like there's enough space. Now we're going to get it to a location, an orientation where it's going to show all of our parts, but also show a nice motion. Now we want to get into this orientation before we start our motion study, because the motion study will kind of take that as a snapshot, if you will, of where it's going to start. So you can't change it easily by going back once you started creating the motion study. So we have this in the orientation we want it. Then we'll go with the motion study here. Okay, you can change this motion study name easily by renaming it. But I'll stick with motion study 1 here. And we have a bunch of different controls and things that are going on here. What we're going to do first, though, is we're going to go to this button here and make sure we use basic motion. Animation just moves things, but it doesn't actually use the physics of physical things running into each other. Basic motion allows you to do that. So, and we're going to change our options here. Now yours might be different. Mine are set at a default of 8 here for the geometric accuracy and the 3D contact resolution. And so you might want to change yours to the 8 that I have here, because a little bit too low might cause problems, too high might cause problems. That brings to mind the fact that this motion stuff can get a little tricky, a little picky, and it doesn't take much for this to cause weird things to happen and to get stuck and so on. So I'm leading you in a direction where this will actually work. Okay, so we've got that taken care of. Now we want to make a motor, make this drive and rotate so that when this rotates, this indexes 1/6 of the way around, or 60 degrees. So when this goes around 360 degrees, this ends up doing 60. But even then, for 300 degrees of this rotation, this one's stationary. So it has an indexing, intermittent type motion. This is the driver, so we're going to put the motor on the driver. So I just click on that button, and it assumes we're talking a rotary motor. We could use a linear actuator here. But what we want to do is click on the component that's going to rotate. So I'm going to click right on this shaft here. And notice how it's going clockwise. I want it to go counterclockwise because I've got this all set up that way. All I have to do to change the direction is click that button. So now it's going counterclockwise. It's set up for constant speed. There are many other things that you can do with that. Just going to keep it there. You can play with that later. 100 RPM is a little fast, so I'm going to change that to 20. And we're pretty much done with our motor. Make sure you click this green check mark so that we can move on to the other things we need to do. Now, if I just do this, it's not going to be good enough. I'm going to click on this button, which is calculate, and so it'll run through the motions of calculating the motion study. And guess what? It runs right through our Geneva wheel, and it makes that noise. So the thing I don't want to have happen is to run right through the Geneva wheel. How do we change that? Also, it didn't go around quite as many times as I wanted to, so I'm going to move this total time out to say 12 seconds. You can make it 10 or whatever you want to do. And we'll do this again. And notice how it started over at my original spot. That's the whole point. It's going to start at that position where you first started getting into the motion study. Then it's going to make that silly noise again. There we go. Okay, now notice we want this to push this. And we use this button here, contact. And what we want to fill in on this field are the things that run into each other. So I'm going to click on this one, and I'm going to click on this. And what the computer will do is it will calculate every single step of the way where these two run into each other, or if they run into each other at all. Now I could use the whole assembly, but most of these parts of the assembly don't run into each other. If I did, it would greatly increase the calculations that the computer would need to make. So we just want to use the things that are going to run into each other. So for now, we're going to do that. And we're going to go back here and recalculate. So let's see what happens here. Oh, much better. Oh, wait a minute. The Geneva wheel is now running into the locking disc. So obviously we need to do something more. And we could let it run out, and maybe I'll just hit the stop button next time. Okay, so what we need to do is we need to modify our contact. Now, if you go back here and click on this, you're going to add other contacts, which can be problematic. What we want to do is go back here, right click, and edit feature. Now, I can do this a couple of different ways. First thing I'm going to do is I'm just going to add this on. What's going to happen, instead of this continuing to rotate, is going to run into our locking disc and stop. Now it's going to vibrate back and forth, which is a little bit weird, but we'll see how this works out. Okay, now I go back through and I add that. So now as this rotates and pushes it, it's going to stop at the locking disc instead of moving through it. There we go. And we are complete. Okay, another way that we can do this is we right click on solid body contact, we edit the feature, and notice it has this use contact groups. Now, this is what you want to do if you have a lot of problems with it calculating too much. I'll delete each of these, and it says contact between the items in the same group is ignored. So the locking disk and the pin are not going to run into each other, so you don't need to worry about them being calculated. So we'll use those in one group, and then we'll have the Geneva wheel itself in the other group. So the Geneva wheel is running into this and this, but these two aren't running into each other. So these are in one group, and this is in its own group. And we'll go back and notice how it's going to start over where I would originally come in. And basically we get the same, and I can just stop it before it plays that annoying noise. There we go. Now you can use some of these other buttons to do different things. We've got springs, we've got some gravity here. You can change up some of the views and so on using this animation thing, or you could even save the animation to a type of movie file. Okay, so this was the Geneva mechanism in using motion study, and in this we used first the setup before we started the motion study to make sure that it was in the orientation and position that we wanted it. Then we came into the motion study and we used properties to make sure that it was doing the right thing in the right ways. And we used a motor and we used a contact. If you want to go for a more expensive package, there are other things in the motion analysis package from SolidWorks that can do more things. But this was a good introductory start.